Awesome. Hi, I'm Eli, and this is Jonathan. We are here to talk about hardware-aware Python packages. PyTorch and WheelNext, grab the wheel. So to give you some context on ourselves, Jonathan here works at NVIDIA on CUDA Python, and I work on the PyTorch developer infrastructure team over at Meta. So first and foremost, I think everybody asks us around WheelNext, what is the goal? What are we trying to do? And I always have a thing, and I just say, pip install torch. And everybody goes, wait, what? We already have that. And no, I mean pip install torch, where no matter what hardware you're running, it'll install the correct version of PyTorch. And I'll kind of go over what are the problems and how we can get to this point throughout this. So what are the problems? First and foremost, the problem number one is that Python packaging lacks the ability to finally describe hardware. What does that mean? In terms of like CUDA versions, in terms of compute capability, ARM versions, special CPU instructions, Python packaging doesn't currently have a way to do this. We have a standard right now that kind of dictates it around like CPU architectures, which I think is really good, and we can follow that pattern as we come into more things around finally describing hardware. So to give you a sense of like what this looks like for the average Python PyTorch developer, I think everybody has experienced this at some point when trying to install a CUDA version where you have to add your extra index URL. It's not entirely clear which index URL you're supposed to use. So this is the example for CUDA 13 for installing the latest version of PyTorch. This is the example for CUDA 12.8 for installing the latest version of PyTorch. And this is the example for CUDA 12.6 for installing the latest version of PyTorch. As you can see, all of these are different, and who knows which one is it's supposed to be. I mean, I know, because I wrote it, but who really does know? And I think at the end of the day, this cannot be the best answer that we have. We must do better. Problem number two, I think, I'm highlighting it right there in our last couple of slides, is around using different package indexes. I think right now we don't have a really great answer for this. External package hosting is just difficult, and it's really difficult to get consensus on. I think there's been a number of PEPs that are trying to address this, and like no consensus has been reached yet, but we're trying. I think there's also a no standard mechanism across installers. So I think whether you've used UV or if you've used pip or if you've used poetry, I think everybody has their own way of specifying index priority, and we have to do better on that. And I think that there's an opportunity for package name collisions across different indices. You know, supply chain attacks are very real. PyTorch experienced one about 3 years ago with the PyTorch Triton package, and so we want to push forward standards that enable people to have the most secure supply chains as possible. And finally, I think it's all about scaling up distribution. Python is becoming more and more popular. PyTorch is becoming more and more popular, and as such, we have to have an understanding that the package size limitations that are currently brought on, because PyPy is a free service, are just not going to be the greatest moving forward as packages get bigger and bigger and bigger. And downloading large packages and binaries is difficult, and we are slowly improving the situation. I think PyPy released the PyPy organizations earlier this year, and we're super excited to be able to try all of these different things out and help push standards forward to help improve the Python packaging situation. And so now Jonathan is going to talk a little bit about wheel variants.
Thanks, Eli. So I'm going to try to present to you the solution that we have come up with pretty much over the last year in collaboration with many, many people. And this is an upcoming standard that we're going to try to propose within the entire packaging community. So this is not official approved work today, but I'm trying to present to you how we envision it. So essentially what we want is, as Eli said, pip install package. And as you do this, the package manager kind of look in the system and say, oh, I see. You have CUDA 12.8 installed on that machine, SM120. So I'm going to look in the registry at all the versions of PyTorch that are being built and available, and pick the one that fits the best this machine. There could be only one, there could be 0, there could be multiple, but I'm going to install the one that fits the best. And we have this working today. You can actually try it. You just need special version of UV that has a special behavior enabled, and it will work out of the box. You don't have to mention any special flag. You don't have to mention a special index. You don't need to do anything special, and that's what we want. It should just be this. So how does it work under the hood? When we build these wheels, essentially you can see a new appendix to the name file that is essentially a label for the artifact. It doesn't carry any meaning aside of being a sort of string identifier, a unique name to that artifact. So there is the CUDA 13, for example, that require a CUDA version lower bound of 13.0 and list a bunch of GPU SMs that this specific binary is compatible with. And then there is a tiny bit about ordering to kind of say, if you can pick this one in priority, if you cannot, just default to that guy. And, well, I like demos because that kind of shows that it works, and otherwise it's just a bit of words. So I have it live. If it doesn't work, I have a video, you know, the demo gods. So just to reiterate, I might need to zoom out a little bit. Here we go. So the one on the left is a CUDA 12.8 machine. My resolution has changed, I'm sorry. Better. So there is CUDA 12.9 on the left and CUDA 13 on the right, as you can see. And we're going to see how doing the same thing on both machines is going to give totally different result. So if I go and install UV on both, and I need a special build of UV, which, just to mention, is built by the UV team. We didn't fork it. UV is directly supporting it as first-party branch, essentially. And if we do UV version on both sides, you can see that we get UV WheelNext, which is essentially this augmented version of UV that is enabled to look into the machine and kind of do these fancy decisions. So that's great. Then we're going to create our virtual environment, because that's important. So I'm going to do the same on both sides, UVVN clear. And then I'm going to install PyTorch without telling it what to do or what type of machine I have. So I'm going to do UV pip install torch on both sides. It's going to download all the dependencies and install everything, which is great. So let's clear the terminal for a bit and just type UV pip list, which is essentially the pip freeze version of UV. And now analyze the different result on the left and on the right and the left. All right. So if you look left and right, you can see that different artifacts were installed. On the left side, we can see versions that actually are not the same between cuBLAS, for example, on the left and on the right. That's normal because he picked the CUDA 13 release or the CUDA 12 release that NVIDIA built. And if we look at Torch, well, we have the exact same thing. Both are Torch 2.9, but they have different builds and different dependency sets. And, well, this is working across architectures. It detects the GPU. So, for example, SM50 and SM60 have been deprecated and are not built anymore for CUDA 13. So if you have an older GPU, well, it automatically detects this and go and install the right version of Torch 2.9 that will support these older SMs. And as a note, now we also ship, as part of Torch 2.9, AMD and Intel version, so this works across the board. And we can start doing CPU optimization, like AVX 512, ARM. Well, it turns out that Mac CPUs are not ARM v7s, so you could actually get a speed boost if you were to use the right acceleration because you know that they are ARM v8 or ARM v9 versions. So all of these things will be out of the box.
Well, one little note about this, too, is that I know that everybody here has experienced the pain of how big PyTorch's wheels are. One of the things that we can really get out of this is building for a singular architecture instead of having to bundle for all of the architectures that we support for specific accelerator versions. And so we can really have a point where we have very, very small wheels compared to the big wheels that we have now. And so this enables that type of work as well.
So I just have 30 seconds, so I'll go pretty fast. WheelNext, we already talked to you about it. It's an open source initiative that includes many, many different companies, many different open source projects. And our goal is to evolve the Python packaging standards to support the scientific compute. It's the work of many people, not just the two of us. And it's important to give them credit for the work that has been done. There's a lot of different projects that are currently on board and shipping these augmented wheels that have better installation story. And we would really love for you to give it a try. If it doesn't work, and if it's not ultra simple, it's broken. and we want to make it better. So please give it a try. It's just a couple lines of bash, and it should just work. If you have any question.
Yeah, if you're also interested in talking to us more in depth about the technical specifications of how WheelNext works, I will be at the Meet the Developers section for PyTorch Dev Infra this afternoon in the exhibition hall. Would highly recommend to come and speak to us. Jonathan will also be at the NVIDIA booth in the exhibition hall throughout the day, so would highly encourage you.
Just right now after the talk also.
Yes, absolutely. So.
Any question? Yes, please.
Will this help with like build versus runtime dependencies for Python packages too, in addition to just hardware?
Like, could you give an example?
PyTorch extension.
Oh, so yes, ABI, we're actually working on it. We were hoping to have a demo, but one of example is VLLM, for example, has a hard dependency on PyTorch, and it will probably be, we are trying to come up with a fix, and we are hopeful for it.
And if anybody has any more questions, we'll be right outside to answer any questions immediately after the session as well. So thank you.
Thanks a lot.